Imagine this. A huge rock, nearly a quarter mile wide, hurtling through space, and it's set to pass us closer than some of our own satellites. Sounds like a movie, right? But this is real. We're talking about asteroid Apophis and its historic flyby coming up. So today, we're doing a deep dive into Apophis. It's a really fascinating asteroid, and its close approach is happening April 13th, 2029. Not that far off. Our mission here is to pull out the key things you need to know, how it was found, why this 2029 event is such a big deal for scientists, and what they hope to learn.
Yeah, and what's really interesting is the name Apophis. It sounds, well, pretty threatening, like the Egyptian god of chaos it's named after. But our sources, NASA specifically, are very clear. There's zero danger to Earth, no impact risk.
Zero risk. That's important.
Absolutely. So instead of a threat, this flyby is actually this incredible scientific opportunity. Astronomers, planetary scientists, they're genuinely excited.
So it's not a near miss we should worry about, but more like a close look, a chance to study something unique up close.
Exactly. It's a gold mine for understanding how our solar system formed way back when.
Okay, let's dig into the story then. Where did Apophis come from? How was it found?
Well, it goes back to June 19, 2004. A team at Kitt Peak National Observatory in Arizona, that's Roy Tucker, David Dolan, and Fabrizio Bernardi, they first spotted it.
Ah, okay.
But here's a twist. They only got to watch it for 2 nights.
Only 2 nights? Why so short?
Yeah, they ran into technical problems and then bad weather, just bad luck,
Huh. So it got away.
temporarily. Luckily, he was picked up again later that year, in December 2004, by another team down in Australia.
Right, right. And I remember reading that initially there were some real concerns about it hitting us.
Oh, absolutely. When it was first discovered and its orbit was still uncertain, calculations showed small but, non-zero chances of impact. People were looking at 2029, maybe 2036, even 2068.
That must have caused a stir.
It definitely did. But that apprehension, it faded pretty quickly, relatively
How did
speaking.
so? What changed?
More data, continuous observations. We're talking optical telescopes tracking it, and crucially, ground-based radar pinging it.
Radar. That gives really precise measurements, doesn't it?
Incredibly precise. Position velocity that let astronomers really nail down its orbit and how gravity from the sun, Earth, other planets would affect it over time.
So now NASA's confident no impact for at least 100 years.
That's the official word. The orbit is now one of the best understood of any near-Earth asteroid. It's a great example of how science refines understanding as more data comes in.
Okay, that's reassuring. And the name. Apophis. You mentioned the Egyptian god.
Yeah, the discoverer, David Tholen, apparently looked for names fitting for a potentially hazardous object and landed on Apep, the Egyptian god of evil and destruction. Apophis is just the Greek version of that name.
Fitting, given the initial scare.
Right. And there's a fun little pop culture connection, too.
Oh.
Tholen and Roy Tucker were apparently fans of the TV show Stargate SG-1, which had a major villain named Apophis.
Ah, I remember that character.
Tholen clarified the asteroid wasn't named after the TV character, but he admitted it was, quote, icing on the cake.
Huh. That's great. Science meets sci-fi.
It happens. And, the name feels kind of fitting given its size, too. It's not insignificant.
Speaking of size, just how big is this god of chaos?
Okay, so the average diameter is about 1,115 feet. That's 340 meters. But it's not perfectly round.
Right. You mentioned radar showed something else.
Exactly. Radar suggests it's elongated. Its longest axis is probably at least 1,480 feet, or 450 meters.
Wow. Okay. How do we picture that?
Think a bit longer than an American football field, or maybe about the height of the Eiffel Tower.
Eiffel Tower sized.
Okay.
That gives a good sense of scale. And maybe peanut shaped.
Possibly, yeah. The data suggests it might have 2 lobes connected, kind of like a peanut.
Got it. So let's jump to the main event, April 13th, 2029. Why is this flyby being called historic?
Well, it's going to be the closest approach to Earth by an asteroid of this size that we've known about so far in advance. That's key.
How close are we talking?
Really close. About 20,000 miles or 32,000 kilometers from the surface of our planet.
Wait, 20,000 miles? That sounds incredibly close.
It is. To give you perspective, many of our communications and weather satellites are in geosynchronous orbit, which is further out, around 22,000 miles or 36,000 kilometers.
So it's coming inside the orbit of some satellites.
That's right. It'll pass well within that belt of geosynchronous satellites.
Wow. Okay, that is close. So the big question for people on the ground, can we see it?
Amazingly, yes. If the weather's clear, people in the Eastern Hemisphere, Europe, Africa, Parts of Asia should be able to spot it.
With the naked eye, no telescope needed.
Correct. No telescope, not even binoculars. It should appear as a point of light moving steadily across the sky.
That's incredible. An asteroid the size of the Eiffel Tower, visible without equipment. How often does something like that happen?
Extremely rarely. An asteroid this large passing this close, it's probably a once every few thousand years kind of event, on average.
And certainly the first time in recorded history we've known about it and had the tech to watch.
Definitely. This is unprecedented in terms of our ability to observe and study such an event.
Which brings us to the science. This isn't just a spectacle, it's a massive scientific opportunity. What happens when Earth's gravity gives Apophis that cosmic hug?
Hey, cosmic hug is a good way to put it, but it's more like a cosmic stress test. Earth's gravity is immense at that distance. It's going to pull on Apophis, stretch it, squeeze it, twist it.
So physical forces acting on the asteroid itself.
Exactly.
Right.
And this gravitational interaction will actually change its orbit around the sun.
How so?
It'll make the orbit slightly larger, meaning Apophis will take a little longer to go around the sun after 2029 than it does now.
And you mentioned its classification might change from Aten to Apollo.
That's right. Right now, it's an Aten asteroid, meaning its average orbital distance is less than Earth's. It spends most of its time inside our orbit. After the 2029 flyby, Earth's gravity will nudge it outwards. Its orbit will become slightly larger than Earth's on average, classifying it as an Apollo asteroid, which spends more time outside Earth orbit but still crosses it.
So we're literally watching orbital mechanics reshape its path in real time.
Precisely. It's a fantastic demonstration of gravitational interactions.
And it's not just the path, right? What about how it spins or tumbles?
Yeah, that's another key area. The gravitational torque, the twisting force from Earth, is almost certainly going to change Apophis's rotation state.
How does it spin now? Is it like a simple top?
Actually, no. It's what's called a non-principal axis rotator, or a tumbler. Think of maybe a badly thrown football wobbling end over end rather than a smooth spiral. It has a complex tumble.
Okay, a wobbler. So Earth's gravity will affect that wobble.
Yes, it will likely speed up or slow down the spin and change its orientation, which way it's pointing as it tumbles.
Could it even cause physical changes on the surface? Like shake things up?
It's possible. That stretching and squeezing we talked about might trigger small landslides or shifts of loose material, especially on any steep slopes it might have. We call that regolith movement.
So by watching how it reacts, how its spin changes, if the surface shifts, scientists can figure out what's going on inside?
That's the goal. It's like, shaking a wrapped present to guess what's inside. By measuring the response to Earth's gravity, we can infer things about its internal structure.
Like how dense it is, or if it's solid rock versus more of a rubble pile.
Exactly. Its density distribution, its internal strength, these affect how it responds to tidal forces. And understanding that is crucial, especially for Apophis.
Why Apophis specifically?
Because it's classified as an S-type asteroid, stony type, made mostly of silicate materials like rocks on Earth, plus some metallic nickel iron.
Okay, S-type. What's significant about that?
S-types are thought to be remnants from the inner part of the early solar system, closer to where Earth and Mars formed. They're different from the more common C-type or carbonaceous asteroids, which formed further out.
So Apophis might be like a piece of the raw material that built the rocky planets.
That's the idea. A relatively pristine sample, about 4.6 billion years old, that can tell us about the conditions and ingredients present when Earth itself was forming. It's like a direct look back in time.
Wow. Okay, this is clearly a huge deal. It sounds like it needs a massive, coordinated effort to study it properly. What's being done?
It really is a global undertaking. You'll have Earth-based telescopes all over the world tracking its position with incredible accuracy.
Measuring its brightness too, I assume, to see how it reflects sunlight as it tumbles?
Precisely. Changes in brightness tell us about its rotation and shape. And then there's radar. Again, powerful ground-based radar systems will bounce signals off it to get detailed shape models and track how its orientation changes minute by minute.
Is there like an international group coordinating this?
Yes, NASA helps coordinate the International Asteroid Warning Network, or IAWN. It's a collaboration of observatories worldwide focused on near-Earth objects. They'll be leading the charge on these ground-based campaigns.
Okay, ground-based is covered. But we're also sending spacecraft, right? Getting up close and personal.
Absolutely. This is too good an opportunity to miss. NASA has cleverly repurposed one of its existing spacecraft.
Which one?
OSIRIS-REx, the one that successfully brought back a sample from asteroid Bennu just last year in 2023.
Oh, right. So what's it doing now?
It's been renamed OSIRIS-APEX. That stands for OSIRIS-Apophis Explorer. It's already on its way to Apophis.
Do what exactly?
It's going to rendezvous with Apophis after the Earth flyby in mid-2029. Its job is to study the aftermath, to see exactly how Earth's gravity changed the asteroid physically.
Fascinating. Study the before and after effects. Is anyone else sending a mission?
Yes, the European Space Agency ESA is getting in on the action too. They have a mission called Ramses.
Ramses. What its role?
Ramses' Rapid Apophis mission for space safety is planned to actually rendezvous with Apophis before the flyby and then accompany it through the close encounter with Earth in 2029.
Wow, so OSIRIS-APEX studies the effects after, and Ramses watches it happen during.
Exactly. One studies the process, the other the result. It's a really comprehensive approach.
That's incredible. 2 dedicated spacecraft plus a global network of telescopes and radar.
It really ensures we capture data from every possible angle. Combining all these observations, ground-based, space-based, before, during, after, will give us a truly unprecedented understanding of Apophis and near-Earth asteroids in general.
So, wrapping this up, it seems what started as a potential scare story has completely transformed.
Totally. It's shifted from a minor impact concern years ago to this unparalleled scientific opportunity right now. Apophis isn't just some space rock. It really is like a time capsule in a natural cosmic laboratory.
Yeah, a chance to see planetary science principles playing out right before our eyes, so to speak.
hmm We've covered its discovery, that interesting naming story. Its pretty substantial size Eiffel Tower big, and how incredibly close but safe it'll come in 2029.
And how Earth's gravity will literally tweak its orbit, change its spin, maybe even cause asteroid quakes or landslides, revealing secrets about its insides.
Right. And the global effort to study it, with OSIRIS-APEX and Ramses leading the space component, just shows how important this is seen by the scientific community.
What really strikes me is how studying this one event, how Apophis reacts to Earth, tells us so much more. It's about the fundamental building blocks of planets like ours and the forces that shaped the whole solar system billions of years ago.
It truly is a window into the past and into cosmic processes. So maybe a final thought for you, our listener, to ponder. As we get this incredibly detailed look at an ancient object like Apophis, how might this knowledge change things? How could understanding these cosmic building blocks better not only deepen our grasp of our own origins, but maybe inform our future steps in space? Think exploration, resources, even planetary defense down the line.
What other secrets do you think these ancient rocks hold, just waiting for us to find the right way to ask? Keep exploring, keep asking questions, and we'll be here for your next deep dive.